All righty, so let's start with just a general question: why solar energy? A lot of people generally are looking for solar for a couple of main reasons. One, it's the environment, reducing our carbon footprint, having a cleaner source of energy, helping the planet. Great reason to go solar. Another big reason that we have for going solar is just saving money on electric bills. Folks are looking to reduce their costs and the energy they're using in their homes or businesses. And it's a great option for them usually. Also, interest in tech. There's a lot of folks out there that are very tech savvy or just like having the latest and greatest, and solar certainly is improving on an annual basis, and it's a great option to be in the know on the latest for tech and everything of that nature. And then it improves the value of a home, and there's certainly quite a few other reasons that folks do go solar, but those are really the main things that we see, at least that I see out in the industry today. So what we'll look at here is, does solar work in Washington and the costs and benefits for solar. We'll look at other uses for solar and a few other resources that you may want to go and check out after the webinar today. So does solar work in Washington? Yes, it does. It works throughout the states quite well. In this irradiance map that is up on the screen right now, we're looking at 1 kilowatt of solar installed and how much energy that kilowatt of solar would produce in various regions around the US. Of course, the Southwest gives us our best production. Phoenix is often considered one of the best places, and here that 1 kilowatt of solar would days that we have here in the US, up in the north. A lot more sun, a lot more opportunity to capture energy from those long days. And solar even works on cloudy days, though not as well, it'll still produce. So it works quite well. Types of solar energy, we're looking at solar electric energy, solar photovoltaics, or PV for short, and that's will be the majority of our focus here today. And then there's also solar thermal technology, and that's gathering heat from solar. And on such a nice day that we're having here today, you can step outside and definitely feel some of the passive energy from solar. But let's start with solar photovoltaics, or PV. Here in the picture, we see an installation in process up on a house. And the goal for the solar PV system is to generate electricity that'll be used inside the home. Most often on rooftops. Sometimes it can be a ground mount system, but it is designed to, again, just create electricity for the homeowner. A typical grid-tied system will have several major components in it, and I'll walk through this picture briefly to kind of say how this system is working. We'll start with the PV array there in the top left. The array is a group of solar panels. Electricity will travel from wires from the solar panels into a DC combiner box or disconnect. The combiner is combining all the inputs into one output for the inverter. There's usually a disconnect on there for safety and maintenance reasons, and that's simply a shutoff. At the inverter, our DC electricity, or our direct current electricity produced by the solar panels, will be inverted into alternating current, or AC electricity, and be sent out to an AC disconnect, again another safety switch item. From there, it'll go to a production meter, and the production meter's goal is just to measure the amount of energy produced by the solar. And after going through the production meter, it'll go into the home to be used by the various items in the home: electronics, appliances, lights. Any extra energy produced then that isn't needed by the home or the business, then will go through the standard utility meter and on out to the utility grid. This is the general idea of a grid-tied PV solar system. Let's look at some vocabulary, and we'll look at some issues to consider when going solar. What we use for determining system sizes, incentives, cost, benefits. This is where we'll head here in the next few slides. So solar vocabulary, I've said a few terms that may not be too familiar. Instantaneous power is called a kilowatt for our purposes. It's basically the amount of power needed at the very moment in which to operate something. Power measured over time is a unit of energy, and this is a kilowatt hour. Anyone looking at their home electric bills will see the amount of kilowatt hours or energy that they've used and they are paying for. How to explain this a little bit is if we were to take 10 100-watt light bulbs, giving us 1,000 watts or 1 kilowatt, we would need 1,000 watts at a given instance in order to turn those 10 light bulbs on. If we were to keep those 10 light bulbs on for a period of 1 hour, then we would need 1 kilowatt hour of energy to do so. Also, the kilowatt of PV produces about 1,100 kilowatt hours a year in Western Washington, around 1,300 kilowatt hours a year in Eastern Washington. That's a reference back to that map that we started with earlier. And in the state of Washington, about average, we're looking at 12,000 kilowatt hours a year per home, but it definitely varies quite a bit. We do a lot of talk with kilowatt and kilowatt hours when talking about solar. Other vocabulary, module or panel. A solar panel or module is basically that most identified item in a system. It's usually up on a roof or on a ground mount. A group of solar panels altogether is generally referred to as an array. And that's what we'll refer to any install. And the array can vary from just 3 or 4 solar panels, 30 or 40 solar panels. It can range in size quite a bit. The inverter, this is the item that's used to convert that direct current electricity to alternating current electricity. Racking is the rails and clamps and other physical material that's used to attach solar panels to a roof or to a ground mount setup that holds the solar panels in place. Production meter measures the energy produced by the solar array. Production incentives, which unfortunately for some are no longer available in Washington, but that is excess energy generated by a system that isn't used by a home and is pushed out to the grid. That's money paid for that excess energy. And then net metering. Net metering is a program offered by the utilities. It's probably one of the great savers for many homeowners. And it's payment essentially, or credits that can be built up on someone's account for excess energy produced. So if the home isn't needing that energy from their solar, then that energy can go into the grid and they can receive credits through the net metering program. That will vary by utility, but it's a very nice program. Some things to consider with solar. Shading is a big deal. The more sun that the solar panels get, the more power that they're going to produce. Trees, distant mountainsides, other buildings, obstructions that cause shade will decrease the amount of energy that the solar panels will be able to produce. Roof considerations, this is looking at the direction the solar panels are facing. They produce best when facing due south. Some roof lines have a ridge that runs north and south, so the open faces of the roof are pointing to the east and to the west. So the solar will still produce, the solar panels will still produce good energy facing east or west, but not as much as if they were facing due south. Other things that consider on the roof might be skylights, chimneys, vents, and all this will play a little bit into that shading factor, as well as just how much solar you might be able to fit onto any given roof. There's only so much available space. HOAs, considerations there to see if they allow solar. Historical preservation societies as well. Some homes are in a historical district and have certain restrictions as whether the society or the preservation group will allow for that solar to go onto the building. And then various policies like net metering will be different from utility to utility throughout the state. Determining system size, how much solar is needed to meet the amount of energy being produced in a home or a business. Factors that go into this, some are financial, just seeing how much energy you want to reduce, how much the budget will allow based on the cost of the system. Another factor, again, is that roof space available. There might not be enough roof space or available land space in which to put the amount of solar required to take care of 100% of the energy needs of a building. And then shading and orientation, the less direct sunlight that is available, then generally a few more solar panels might be needed to produce the amount of desired energy from the system. So installers use various software packages and take online measurements as well as on-site measurements to look at shading and orientation and other factors in order to calculate or estimate the size of system that's needed based on the amount of power that the goal for that system to produce is. So there's a good way to recoup some cost through incentives and credits that are out there. When purchasing solar in Washington, and this is actually throughout the states, there is a 26% tax credit in place, and that's in place for the duration of this year. And it says that the amount of money you spend on a solar system, 26% of that total cost will be credited to you through a federal tax credit. In 2021, this amount will reduce to 22%. And in 2022, on the residential side, the tax credit is set to expire. Commercial systems will still be able to take a 10% tax credit in 2022 and a few years after that. In the state of Washington, we have a sales tax exemption in place. So when purchasing solar through 2029, no sales tax will be charged for that system. So that's a small bit of savings there as well. Currently, as mentioned before, there aren't any state incentives. We'll see if incentive packages come in the future, but nothing is available today. And then sometimes there's local incentives. And again, this is going back to the utilities, see if they have a program on just providing some extra financial help in adding renewables to a business or home location. The net metering program is in place for any system that is under 100 kilowatts. Excess energy that is generated and pushed to the grid, credits will go to the account and help cover the cost of the electricity used at that location. And the last item said here is the marks. This is a federal program for businesses in which they can have a deferred tax rate, and just helps them on a taxable situation financially when choosing to add solar or renewables to their business. Let's look at some sample costs here. I'm going to use $3 a watt for a 10 kW system. So at that basis, a system there would cost $30,000. Now this is kind of a rough number, but a fair number to use when kind of guesstimating or getting a ballpark figure for solar, even if you were looking at it for your own home. This would not include any rebates, tax credits, or tax exemptions. If we start with this $30,000 cost, 26% federal tax credit would see a return of $7,800. Given our annual average production, I'll use the example in Seattle at 1,100 kilowatts per year per kilowatt installed. Our system should generate about 11,000 kilowatt hours a year. And then looking at that, I have chosen to use 9 cents a kilowatt hour for the cost of power. And that there is going to stay steady throughout our 25-year example. Certainly most people are paying a little bit less than that right now, but in 25 years, I'm pretty sure we'll all be paying a little bit more than that amount. But for the example here, that 9 cents at the 11,000 kilowatt hours earned would create an annual average savings of $990. and over a 25-year period would give us that $24,750 in money not spent on the utility. That's from the energy we've produced ourselves. So in the end, we would end up after 25 years with a total savings of $2,550 in this example. And we see the $30,000 spent, we're in the hole, and then we get the $7,800 from the federal tax credit, and then $24,750 saved over the period of 25 years. I'm sure if you were to look at a quote today for a system, the numbers would actually be a little bit better than what they are here in this example. But the goal here is just to get an idea of what the numbers are and how they work. Other benefits of having solar, it increases the home value. The value increase is generally equal to the amount of savings from the electrical bills for a period of 20 years. Long warranties. Panels are producing about 80, or they're warranted to produce about 80% of the power from the original date of install at 25 years later. So in 25 years, you should see at least 80% of production from your panels. Reducing carbon emissions, helping the environment. That's multiple years of gathering energy from the sun versus from coal or other carbon emissions. Solar is a static item. There's no moving parts. It's generally low to no maintenance, nothing to really worry about breaking down over the years. Though things do need replacements, inverters are usually replaced in about 12 to 15 years after install, just part of a system. And then the sun, and hopefully it'll just keep on shining, and we have lots and lots of sun to go through the years and produce a lot of electricity for us. And then again, it creates local jobs for the installers that are out there working in the industry. In the state of Washington, we have several companies that are local. Some of them are bringing in product from overseas or around the states, but they are here in Washington. Silfab is making solar panels. We have Outback Power and Midnight Solar doing a lot of balance of systems products, inverters, combiner boxes, all kinds of items that are needed in an actual install. Sunmoto doing a lot of racking and ground mount solutions. Blue Frog or AP Systems, they're doing micro inverters, just miniature version of the inverter. And then Silk Road Solar out of Tri-Cities is providing water or solar thermal solutions as well. So Washington's got a lot going on for solar. Just wanted to share some of what is out there in our state. I've mentioned about checking with the local utility from time to time so far, and Washington has more than 60 utilities throughout the state. And it takes a lot on the grid to kind of organize and figure out how to manage power throughout those 60 utilities. And each of them operates a little bit differently. So if you're looking at solar, some things to keep in mind through the utility are the interconnection application, the net metering application. There could be additional fees for an added meter for having solar. There could be additional fees for administrating the utility account or change to the base rate. There's a few variable factors from utility to utility. So anytime considering solar, getting in touch with the local utility is a good idea to see what they have to say or what they can recommend for you. And by staying with a local installer in your search for a potential installer, generally the local installers know the local utilities and they have a good working history and understand a lot of these special instances that are out there. So in going ahead with an installation, for anyone looking at installing, getting multiple quotes is in your best interest. Don't succumb to high pressure sales. There's plenty of folks out there installing and doing a good job at it. Again, you can check with your utility. Many times they will have a list of, not that they're recommending them, but these are known local installers for the area that they have done business with. And one thing to check from local installers is, do they outsource any work? Who all will be working on your system? Is it just everything is located in one spot, or if they outsource any work, the concern there is, are they licensed and bonded and insured? as a company, and are the subcontractors also licensed, bonded, insured, and make sure they do a good job on it. When looking to finance solar, there are banks out there that do special solar loans. Some of those credit unions are listed here. And then, of course, checking with your own local bank or credit union to see what they have to offer as well. Maybe we should start it here at the beginning, reducing your usage. The best thing you can do for your home or business really is to try to reduce our energy being used, and this is keeping lights off that really aren't in use, switching over to LEDs, improving insulation. Sometimes local utilities have some incentives as far as improving the windows or improving the HVAC, or reducing the amount of energy used. When that happens, the amount of solar needed to produce the amount of energy required is less, so the costs go down, and it's a great way to go about it. But that's a great first step there, is reducing the usage. And then keeping it shade-free. If there are trees that start to grow, be aware of what's growing around the system. And then every once in a while, hosing off the panels just helps them produce a little bit better. They don't need any great attention. Usually they run pretty well with a light rinsing. And I know here in Eastern Washington, we're coming upon pollen season, and any system is due to get quite a bit of pollen on it in the next month or so. So let's at some of these other types of solar out there. We'll look at solar thermal. And one way we see this is in passive solar and heat that we get. This will happen in building design. Windows, if you've been in a wintertime situation, you're standing next to a window inside, even though it's cold out, you can still feel the hot heat from the sun coming through that window. And the goal in passive solar is to capture that heat in various ways. With windows oriented just so, wintertime, that sun is shining through. With eaves sticking out, summertime, those eaves will create shading and help limit the heat coming in to a building. Also with good ventilation, allowing cool air in and hot air out, a well passively designed home will need less energy for heating in the winter and cooling in the summer. Another type of solar thermal, which is quite popular, is solar hot water. And here we see evacuated tubes in which a water and kind of an antifreeze mixture would flow through and collect the heat from the sun, and then flow down into where the hot water tank might be to transfer that heat to hot water, or possibly radiant floor heating. It's another option out there to collect heat from the sun and then transfer that into hot water systems. This can also work with air. And these here to me on this photo look like little air mattresses on the windows. And the solar there then heats the air mass. And then that air mass gets moved around through a series of fans for ventilation systems, again, to transfer the heat into the home or business. And this situation here in the summertime, this here would also act as shade on the windows to limit the amount of heat shining in through the sun. There are other ways to participate in solar. We do have a number of low-income communities and families and challenged communities that maybe don't have the infrastructure or the option to really jump into having solar very easily. And community solar is a great opportunity for folks at low investment costs to take advantage of benefits that come from solar, whether it be just reduced bills or credits that would help them in a taxable situation. But community solar is a great option to participate in solar without actually having solar on your home or business. And again, that's something to check with the local utility about to see if they have any community solar projects taking place. I want to share a few stats from the last couple of years here in Washington. Right now, there are a little over 3,700 jobs in the state for solar. We did see a small reduction between 2018 and 2019 in jobs, about 6.5% loss. In 2019, state incentives closed, and fewer people were choosing the option of solar. This did put a little strain on the industry in general, and jobs did go away, but we see those jobs returning in 2020. I think the numbers will look better again for this year. In 2018, when that incentive law passed and went into effect, there was a lot of growth in the state. And then on a national scale, we have almost 250,000 jobs, and the growth rate of the solar industry is increasing at a much larger rate than the rest of the U.S. economy. So solar is growing well here in the state and across the U.S., and it's going to be an industry that I believe will just keep on growing and running strong. So I get this question about future applications as well as what's the next greatest thing, and I want to take just 2-3 minutes here at the end to look at a few things that are out there and that are up and coming, though aren't readily available. Solar shingles, thin film, solar glass, and liquidized solar cells or perovskite. This is just a brief look, but as we can see in the photo, there could be some very interesting ways that solar gets introduced to us in our communities. Head in the right direction. Solar roof tiles. Tesla has a product out that's pretty well known. They're working on getting it to market. There's a bit of a waiting list, but certainly if someone were to re-roof their home, adding 20 to 30% cost to that project and having solar tiles that would create energy for the home would make a lot of sense. And I think in coming years, we'll see this technology have a better transition to market and costs come down where it's a bit more affordable. On the right here, we have RGS Powerhouse. This is a company that's installing today. It's a product that's available. It's a very flat solar panel that integrates in with the roof shingles. Interesting technology. It's very low profile and kind of an artificial solar tile. Thin film has been catching up with our standard PV panels that we see. It's very low profile, it's lightweight, easy to install. It installs faster at a lower cost. The efficiencies aren't quite as good, but not very far behind our standard solar panels. It costs a little bit more, but we have a lot of application opportunities with thin film, and I think we'll see this pop up in communities more and more in the next few years. Solar glass, this is what we call building integrated PV. And there's a picture here with the University of Washington. They were the first to have solar glass in the state. This is the Life Sciences building on campus. And all the vertical fins or lines that you can see on that main photo are all solar glass PV modules, and very aesthetically pleasing. It allows architects to do a lot with their designs of buildings and public spaces. The transmission of light through the solar glass is pretty exciting. It makes it look very nice. Not very efficient and still quite expensive. But I have listed here Onyx Solar. They're a company out of Spain. They're considered the world leader in this. So if you were curious to find out more about this technology, that would be a great place to go take a look. And there's another building in Seattle currently. I don't know if it's complete, but getting solar glass as well. It's a pretty aesthetically pleasing solar system to see. And it does work fairly well, but again, lower efficiency, a little bit higher cost. And lastly, the idea of printing solar cells on just about any material. There's a material or a mineral out there, perovskite, that they can liquefy and create solar cells out of. The manufacturing cost is much lower, much higher efficiency on the material. Applications are exciting to think about, but it has a short lifespan. It tends to degrade much faster in direct sunlight than the traditional solar cell made out of silicon. This is a pretty exciting technology that I've watched for several years, and I'm hoping that Solar Washington will have a future presentation on perovskites and what's happening here. But it's out there, and it's exciting and interesting to see. A few other resources. Again, we are Solar Washington. I encourage you to come to our website and check us out at solarwashington.org. Government has a couple websites that has great information and resources. NREL, or the National Renewable Energy Laboratory, NREL.gov is an excellent source for more information about solar, as well as the U.S. Department of Energy. The Desire database is an excellent resource for various incentives that are there. They have it state by state and down to the local level. Again, listing just about everything from local to federal incentives that are available. And there's this Google Project Sunroof, and this has been in operation for a few years. It's growing, and it's essentially giving you the opportunity to see how much energy solar would produce on a given building. It's a bit of a design tool, and I'm sure, like most tools with Google, they'll keep working at it, and it'll grow and become more and more known over the coming years. I want to take a moment here. A lot of folks put in time to put this presentation together. Spark Northwest, Western Solar, A&R Solar, and Puget Sound Solar, Ryan Brandt, Snohomish PUD, and then various board members from Solar Washington. Thank them all for their contributions to making this presentation available. And then, as Patrick mentioned before, feel free to contact him with anything about Solar Washington. And then any questions on today's presentation. I know it moved pretty quick, but trying to stay at that 30-minute mark. Feel free to send me an email with questions. And right now, I'll go ahead and pass things back to Patrick, and we'll go ahead to answer some of the questions that come up.
Great. Thank you, JJ. Are you able to hear me okay?
Yes, I can.
Fantastic. First of all, I'd like to, on behalf of Solar Washington, thank you, Jay, for volunteering your time for giving this presentation today. Very, very good of you to do so. And also, just as an aside, thank you all for your patience concerning this presentation. Earlier, I had a couple of technical issues and trying to figure out the interface, so thank you for your patience on that. What I'll do is, we do have a few questions. I'm going to read the chat sidebar from top to bottom and try to get in as many questions as possible. Won't be able to do them all, but anyway, we're going to start from top to bottom. Jay, we have a question. What does it take for home installed PV systems, maybe with a battery inverter, to provide AC power when there's no utility tie because of a power outage?
Okay, very good. Yeah, so our example was just looking at a grid-tied system that would shut off when there's no power. That's a safety factor so that power doesn't get pushed onto the grid while linemen are trying to make repairs. To have AC power available, the inverter needs to see some type of power source. And with that, it's basically a battery supply. Having a battery available and a bidirectional inverter that can charge that battery and draw power from that battery, it can create a signal similar to what's coming from the utility that will allow the system to work in a situation where there's no power. So the battery would be required to have the solar system continue to produce power for the home during an outage situation.
We do have an additional piece of information from one of our listeners saying the first thing to consider when determining system size is to know what the existing load is. That information can be obtained with customer permission from the local utility. So thank you for that particular comment. Another question, do we think that the federal tax credits will be renewed? Jay, do you have ideas on that?
So on the federal tax credit, there was a movement in Washington, D.C. earlier in 2019 to try to extend the 30% credit. This is where it was at last year through 2025. I don't think that gained a lot of ground on the floor. I think it was in the House of Representatives that came up. Possibly, I think there are legislatures in D.C. that would like to see some form of tax credit come back or maintain. At this point, it's in discussion. I don't know of any law changes or anything that have made it certain. For the state of Washington, incentives that might be available similar situation. I think there are packages out there that folks are trying to see get through, and there might be options in the future for incentives, but currently there are no incentives for the state of Washington.
We have another question. Our roadblock is roof life. We're 19 years into a 30-year roof. Any suggestions?
Yeah, that's a little bit of a challenge, because you look at, well, if I put solar on my roof and then 15 years from now or 10 years from now, I need to pay to have it all come off, have a new roof put on, and then have the solar go back up. And some of that is just, that's how it works right now. I don't know if I have a very good answer for that. It's just plan to know that at some point that's going to be part of the process. I do know that the cost for removing the panels and having a roof redone and put back up aren't extraordinarily high, because everything's laid out and done. It's just a removal process and then a reinstall process. If the roof is close to end of life, and I see this from time to time in my job function, is that we will often talk to the homeowner about considering replacing the roof prior to adding the solar.
A couple more questions here. What does it mean to be bonded and insured, and why does that matter?
So the bonding and insurance for a company is, let's say they start working on your home and then they leave, or there's damage done and they won't say, hey, you know, we're not going to cover the damage that we did. That's where the bonding insurance comes. Bonding makes sure that the work gets done, and if somebody else comes in to do it, the bonding should cover that cost, and that if there's any damages that they are responsible for, the insurance is there to cover that if they will not do so.
Another question, what are your thoughts on concentrated PV, multi-junction cells? Question, not a viable future tech? Any thoughts on that?
Yeah, well, concentrating cells, I've seen them both for electricity and in heat. Sevilla, Spain, down in Bakersfield, California, they have some concentrated solar plants, essentially using that heat for boiling water and doing energy generation and steam plant. On the manufacturing side, I've seen some PV with concentrating cells for electricity, where the light is reflected on a very, very small solar panel, essentially, a small solar cell. And the efficiencies are really good, but the cost of manufacturing panels like this and then the maintenance on them are a bit higher. In the end, generally technology gives way to budget. And so I think they'll still continue to do research, and we'll see things out there for concentrating PV. But just due to the costs of it, I don't see it coming to market anytime soon.
Okay, and we have time, I think, for one more question, and apologies again to those questions we are unable to get to, but as I mentioned, we're going to have this presentation on our YouTube page. I will get it up there in due time. Let's do one more question. Let's see here. We have a farm property with very little power use. Would we be paid for all production if it is more than we use? Is investing in solar for farmland use viable?
I have two comments there. One, on the being paid for excess electricity, generally your account is credited. Sometimes the idea is out there is, if I put in lots and lots of solar panels and I'm generating a lot of electricity, then I can sell all that electricity to the utility and get paid for it, and it can be a source of income. It's not going to work that way. What the utility has set up is they'll credit your account, and the goal there is that you might be able to zero out your electricity bill. You still have the base rate to pay each month, but any use would be provided by the solar. All excess credits that get built up on your account, on an annual basis, the utilities will roll over their accounts, and I believe that's March 31st, and it'll zero out those credits. So in any good design, trying to zero out your bill, you should be producing roughly the same amount of electricity that you use on an annual basis. A second comment is if you're on a rural farm area, regardless of the amount of electricity being used, looking at the REAP program. You can find that on the Desire website. You can send me an email and I'll be glad to give you a little information on it. But if you're in a fairly rural location, there might be incentive dollars to help cover the cost of an installation.
Yeah, speaking of the REAP program, the grant process application closing has been extended to April 15. There's more information on our website. If you go to our homepage, solarwa.org, there should be a direct link to more information about that particular program. And also, seeing some of the comments, we do have additional resources on our website, solarwa.org. For example, we do have a page on community solar. It doesn't necessarily have an update vis-a-vis the bill that was passed and actually vetoed by the governor over the last few days. But we do have a page on our website about that. We do have a page also on our website about, in terms of if you're considering going solar, what questions to ask an installer. We have a list of, goodness, 20, 25 questions that would be really helpful as you determine, what makes sense to do and what questions to ask an installer. So I think with that, that'll conclude it. Jay, thank you so much for all of the time that you put into this presentation today. Greatly appreciate it. And folks, thank you very much for listening in this afternoon. Again, a lot of information at solarwa.org. And again, as I mentioned, if you're in the position to support Solar Washington, we're a nonprofit organization. We're about education. We do a number of things throughout the year, both in-person events and things like this. And also, if you have any other suggestions in terms of webinar ideas, let us know. You can email me at patrick@solarwa.org. Other than that, thank you all so much for your time, and stay safe out there, and we'll see you down the road. Thank you so much.